Morning everyone. This is a demonstration of a grid pathfinding algorithm that I was working on for some time, and I believe I have an executionable model ready to present. So what I've done is, as you can see right here, is in the top upper left screen. If you can just work on this part only for the time being. So as you can see over here, this is a grid system that I've created through C# scripts and with the help of Unity. So what happens is that such is the ground that one needs to navigate on. That ground is within an A star, which is the name of the algorithm that is being used here, is encapsulated within the A star grid. And whenever I run the scene, these red blocks, which are known as obstacles and non-walkables, in this case, are portray the grid in such a case that wherever the user, which is the blue capsule over here, is standing, it's gonna show where the user is standing, and then also direct the shortest or route out the shortest path from the user to the object or the destination where the user wants to go. And it will also use these non-walkables as a, what do you call it, in consideration, so that it does not actually passes through walls, because like navigation, you cannot actually pass through walls in general. So for the time being, I'll just group all these non-walkables under one class if possible, just to make it a little bit neater. So we'll take all of this, group it under here. So this is the person, this is the plane. For the timing, work on the camera can be done, but these two are not important as of right now. These main things are this. So once I hit the play button, and it's gonna take some time. As you can see, a grid is created. So the gray blocks, or in this case, the white blocks, uh, show the walkable area, or the area that the user can navigate on. The red blocks are the places where the user cannot navigate in. So if I go in an orthographic view, and if I zoom out of that view, let's say right here, as you can see, all the walls are being sort of surrounded by red blocks, the walls where or areas that user cannot walk on. And they are scalable, and they change as per scale of the uh, what do you call it, the setting of the engine. So let's say if I, not this part, but if I change this to 3 or 4, while it's not showing it right now, if I run it again, if I run the script again, and it goes back to 3, 1, I mean, if I run this again, you see this is the grid became flexible as per the physical mesh of the 3D object that is categorized under the non-walkable category. Similarly, for the user, what I've done is to track the user on the grid. So what happens is that whenever the user is moving, the grid is taking note of the position in terms of a blue square. So if I zoom in on it a little bit, there is a red square, a white square, and a gray square. So gray square resembles walkable area, red square resembles a non-walkable area, and the blue square resembles the position of the current character or the person who wants to navigate. So the grid will take in the position of the character, and on basis of that, it will take another position, that is the set destination that the person wants to go to, and it will calculate the shortest path between the two areas, uh, between these grid points. So how can magnet maps can be implemented into this? So all I need to do is put in a simple image. There is no requirement of 3D model, no requirement of programmable path for that matter, although there is some requirement for certain alterations within the engine itself, because I'll have to put them in within this. So if, as you can see, if I close this, this is hideable. So it's not actually presentable in the upper screen or the lower screen, but the mesh still exists. The non-walkable path still exists. So that way, what we can do is we can just use the image of the magnet floor apps or floor maps and just create a sort of a path which is navigatable and which is not navigatable, and then use the A star algorithm to calculate the shortest distance between point A to point B. And that will be all for today. Thank you.